Grace and peace to you all. Prove that gamma of 1 over 2 is equal to square root of pi. Okay, so on this video, we are going to prove that gamma of half is equal to square root of pi by using the definite integral definition. Okay, so second form of definite integral definition states that gamma of z is equal to 2 integral from 0 to infinity of e to the minus t squared and t to the power 2z minus 1 dt. Okay, so gamma of half. So where there is z, we are going to put half. Okay, so we are going to have gamma of half is equal to 2 integral from 0 to infinity exponent of let's have it in two forms. Let's have x in terms of x as well as in terms of y. Okay, so where there is t, we are going to put an x. So exponent of minus x squared. So if we put 1 over 2 where there is z, if you put 1 over 2 here, it will be 2 multiplied by 1 over 2, it will be 1. 1 minus 1 is 0. So we are going to cancel out this t. So we are going to remain with just the x. That is in terms of x. And let's have it in terms of y. So again, let's have gamma of 1 over 2 is equal to, so where there is z, we are going to put an half, and where there is t, I'll put y. So we have 2 integral from 0 to infinity of exponent of minus y squared. Then if you put half there, the t will cancel out. It will be power 0. So dy. Okay, so we have two expressions for gamma of 1 over 2. We have this one and that one. Okay, so what are we going to do? Okay, what to do here, we are going to multiply the two expressions. So we are going to have gamma of half multiplied by this gamma of half. So it will be gamma of half squared is equal to, so when you multiply these two, you just combine them. So we are going to have 2 integral from 0 to infinity of e to the minus x squared dx multiplied by 2 integral from 0 to infinity of e to the minus y squared dy. Okay, so gamma of 1 over 2 squared is equal to, so when you multiply these two, we'll get 2 multiplied by 2 is 4, so we have 4. Then we have integral from 0 to infinity. Again, integral from 0 to infinity. When you multiply exponent of minus x squared multiplied by exponent of minus y squared, we are going to add the powers. So we get exponent of minus x squared plus y squared. Then we are going to have dx dy. Okay, so the next step is we are going to change the x and y into polar coordinates. Okay, convert to polar coordinates. So in polar coordinates, x is equal to r cos theta, and y is equal to r sin theta. Okay, so we need to convert dx dy. So dx dy, we need to convert it to d theta. Okay, so this is equal to the partial derivative of xy with respect to partial derivative of r theta. Okay, this will give us, we are going to have the modulus then this should be in terms of dr and theta. Okay, so first we are going to differentiate we differentiate x with respect to r. So dx dr will get this is r cos theta with respect to r will get cos theta. So we are going to have cos theta here. The next we'll say it's dy dy dr. So dy dr will be derivative of r sin theta with respect to r will be just sin theta. So we'll get sin theta. Okay, then we move on to dx d theta. So derivative of r cos theta with respect to theta will be, the derivative of course is minus sine. So we are going to get minus r sin theta. Okay, then move on to dy d theta. So derivative of r sin theta with respect to theta. Okay, so sin theta, derivative of sin theta is cos theta. So this will give us r cos theta. Okay, then we find the determinant for this. So you just cross multiply. Okay, so cos theta multiplied by r cos theta will get r cos squared theta. Then this will be minus, this is minus r sin theta multiplied by sin theta. We'll get minus r sin squared theta. Now there is a minus here, so it will make positive. So plus r sin squared theta. Then we have dr d theta. Okay, we can divide out r here. So when you divide out r, in the brackets we are going to have cos squared theta plus sin squared theta. And we know that cos squared theta plus sin squared theta will give us a 1. So 1 multiplied by r d theta is just r d theta, and we have r outside here, so it will be r dr d theta. So that is what we are going to substitute. Where there is dx dy, we'll put r dr d theta. Okay, the next is we need to change even the limits. Okay, so limits, we start with x. So the limits for x is from 0 to infinity. So x is changing to r. So where there is x, you put 0 here, then r will be what? 0 divided by cos theta, it will be 0. So r will be 0. When x is infinity, infinity divided by cos theta, it will still be infinity. Okay, so the limits for r will be from 0 to infinity. We go to y. Y is also from 0 to infinity. Then y is changing to theta. Okay, so where there is y, if we put 0 there, 0 divided by r will be 0. So if you say sine theta is equal to 0, if sine theta is equal to 0, it means even theta should be 0. So we have 0. Okay, if we put infinity there, infinity divided by r, you get infinity. So if you say sine theta is equal to infinity, infinity in this case simply means the maximum, and we know that the maximum value for sine is 1. So if we say sine theta is equal to 1, it means theta should be 90 degrees. That is pi over 2. So where there is theta, we put pi over 2. Okay. So we substitute those limits. Okay, so we say gamma of 1 over 2 squared is equal to, we are going to have 4 in integral, that is from 0 to pi over 2. Okay, that is for theta. Then for r, we are from 0 to infinity. Then we have its exponent of minus, where there is x squared and x squared plus y squared, we are putting r cos theta for x, then r sin theta for y. So it will be r squared cos squared theta plus r squared sin squared theta. So if you divide out r squared, in the brackets we are going to have cos squared theta plus sin squared theta, which is just 1. So we are going to have exponent of minus r squared. Okay, then where there is dx dr, we put it's rd, it's r dr d theta. Okay, so what next here? What next here is we can substitute here, where there is r squared, we can substitute with any letter. So we can say let u equal to r squared. Okay, let u equal to r squared, meaning r is equal to square root of u. Okay, and when we differentiate, it will be du is equal to, this is 2r dr. Okay, so since here we have r dr, we can make r dr the subject of the formula. So here it's just a matter of dividing 2 to both sides of the equation. So we are going to have 1 over 2 du is equal to r dr. So where there is r dr, we are going to put 1 over 2 du. Okay, and where there is r squared, we put a u, and the limits will be maintained. Okay. So we have gamma of 1 over 2 squared is equal to, we have 4 integral from 0 to pi over 2, again integral from 0 to infinity, then we have e to the minus, so where there is r squared is u, so the minus u, then where there is r dr, it's 1 over 2 du, then here d theta. Okay, so these two can go in 4, you get 2. So we are going to have gamma of 1 over 2 squared is equal to, so we have 2 integral from 0 to pi over 2, again integral from 0 to infinity of e to the minus u, then du d theta. Okay, so gamma of 1 over 2 squared is equal to 2 integral from 0 to pi over 2. The integral for e to the minus u is minus e to the minus u. So we are going to have minus e to the minus u. That is the integral. Then the limits is from 0 to infinity. Then we have the theta there. Okay, so gamma of 1 over 2 squared is equal to, so we have 2 here, then integral from 0 to pi over 2. Then when you substitute here, so if you substitute infinity here, this whole thing will be 0, so 0 minus. If you put a 0 there, it will be a 1. So minus and minus 1 will give us a 1. 1 times the theta, you get the theta. Okay, so the integral of the theta is going to be theta. So gamma of 1 over 2 squared is equal to, we have 2 here, then the integral of the theta is theta. Then the limits is from 0 to pi over 2. Okay, so gamma of 1 over 2 squared is equal to, we have 2. When you substitute pi over 2 here, it will be pi over 2. 0, it will just be 0. Okay, so these 2 and these 2 will cancel out. So we are going to have gamma of 1 over 2 squared is equal to pi. Okay, what we are looking for is gamma of 1 over 2. So here we have gamma of 1 over 2 squared. So to get rid of squared, we are going to introduce the square root to both sides of the equation. So square root both sides of the equation. So if you introduce a square root here, it will be gamma of 1 over 2. So the square root will cancel out the power 2 is equal to, in this side, square root. So you can see that we have shown that gamma of 1 over 2 is equal to square root of pi. Hence, proved. So always remember that gamma of 1 over 2 is square root of pi. So this is another property of gamma functions. So gamma of 1 over 2 is equal to square root of pi. Thank you so much for your time.